So we began yesterday talking about how changing the y-intercept is going to shift our graph up or down, or translate our graph up or down. And we talked today about how the slope changes things. And the slope either vertically stretches or compresses the graph. And we could also say, we could use the words that it's going to make it steeper or it's going to make it less steep. That's also another way to describe that. So we could say that if it stretches it, it's making it steeper. That's going to be making it taller. And if it compresses it, that makes it less steep. So what happens is that as m gets bigger, as my slope gets bigger, it's going to be a stretch, or it's going to make it steeper. And as m gets smaller, it's going to compress it or make it less steep. It's also important to remember that the negative sign there is going to reflect the graph over the y-axis. That's what the negative sign does. So if you had slopes of -4, if you had a slope of -4 and you had a slope of +4, then that means that they're the same steepness. They're the same steepness, they just go different directions. The -4 is going to go down, -4 is going to go down and the +4 is going to go up, but the lines are equally steep. So the slope of f of x equals 4x plus 2 is cut in half. How would this affect the graph? So my slope is currently 4x, that's the number there in front of the variable, it's just the 4. If I cut that in half, then my new slope is going to be 2, because half of 4 is 2. Well, since my slope went from 4 to 2, it decreased, so my line is going to be a vertical compression, or we would say that it is less steep, because again, they mean the same thing. So we could say it's a vertical compression, or it would be less steep. If the function f of x equals 1/2 x plus 5 is changed to g of x equals 2x plus 1, how is the graph affected? Well, my slope was 1/2, now it's 2, so it got bigger, that's for sure. So that means it's a vertical stretch. And we need to figure out what the factor was by a factor of. In order to figure out that factor, in order to figure out the factor that it was stretched by, we always take the new and divide it by the old to get the factor. So my new slope was 2, my old slope was 1/2. If I divide 2 by 1/2, what that's asking is how many times does 1/2 go into 2, or how many halves are there in 2? Or you can think of it as how many 50 cents are there in $2. And that works out to be 4. So this is a vertical stretch by a factor of 4. So our next question says, what happened to f of x to obtain g of x? So if we look, f of x is the blue graph, g of x is the red graph. Well, one thing that happened is their y-intercepts are different. So that tells us that the graph shifted. So if it started at f of x and it went to g of x, it went up 1, 2, 3, 4, 5 units. So it shifted up 5 units. So that's one thing that happened. So the other thing that happened is it looks like the slopes are different. So we need to actually figure out what those slopes were. In order to do that, I need another point on each of the lines. So I have another point here at +1, 3. So I'm going to find the slope of the blue line by counting up 1, 2, 3, 4, 5, and over 1. So the slope of this line is 5 over 1, or just 5. Well, I need to do the same thing for the red line. I need to find another point. So it looks like I have a point here at -2, +1. So I can find my slope by going up 1, 2, 3, 4, and over 2. So my slope of my red line is 4 over 2. So that means that the slope of the red line is just 2, because 4 over 2 is 2. And the slope of the blue line is 5. So if the blue was 5, this was the initial. Remember, this is where we started at, was 5, and we went to 2. Then my line got less deep. It's a vertical compression. It's a vertical compression because it went from 5 to 2. It went from 5 to 2. So it's a vertical compression by a factor of, remember to find my factor, I always put the new over the old. Well, my new slope is 2. My old slope is 5. So it'll be a vertical compression by a factor of 2 over 5.